Section 8.2 talks about lines and slope. We start by looking at a table of values. A table of values is simply a table that lists x and y values that make an equation true. It gives you a list of points that you can plot on a graph in order to draw your line. So the lines that we're looking at here are all going to be straight lines. This is a linear equation. You know it's a linear equation because the power on the x and y is 1. And later we're going to look at how to graph this using two other methods, intercepts and slope-intercept. So my equation gives me a relationship between x and y. Tells me that when I take x and add 3 times y, my sum is 12. If I know the value of one of these variables, I can substitute it in to get the value for the second variable. For example, when x is 0, that x term drops out and it leaves me with 3y equals 12. You could solve that equation by dividing both sides by 3. 3 divided by 3 is 1. That'll leave you with the y. And 12 divided by 3 is 4. So when x is 0, y is 4. That gives you the ordered pair 0, 4. Okay. If I choose y equals 0, when y equals 0, the y term drops out. 3 times 0 is 0. And it leaves me with x equals 12. So x is 12, when y is 0, that gives me the point 12, 0. Here it says x is 3. When x is 3, I'm going to do that here. I'm going to get 3 plus 3y equals 12. Start by subtracting 3 from both sides. On the right side, 12 take away 3 is 9. You get 3y is equal to 9. Divide by 3, and you get y is 3. So the point 3, 3. When y equals 6, I'm going to get x plus 3 times 6 equals 12. 3 times 6 is 18. So let me just subtract 18. Minus 18. And you get x is equal to negative 6. Notice that it doesn't matter what values you choose here. You could choose any values at all. It's a good idea to choose some positive and some negative. If you only choose positive, you're only going to get points on the right side of the y-axis, or only above the x-axis. So it's a good idea to have a variety of points. When x is negative 3, I'm going to get negative 3 plus 3y equals 12. isolate the 3y by adding 3 to both sides. And that's going to give me 3y equals, whoops, that should be an equal sign, equals 15, and then divide by 3. 15 divided by 3 is 5. So this last point is a point -3, 5. So on this grid, I purposely left off any scale. I notice I have 1, 2, 3, 4, 5, 6, 7 units to the right, 1, 2, 3, 4, 5, 6, 7 to the left. So if I'm going to plot this point 12, 0, it would be way over here to the right. Instead of using a scale of 1, I'm going to choose a scale of 2. So each mark here is going to be 2 units. That's 2. That's 4, that's 6, and so forth. You can use a different x-axis scale than a y-axis scale. My y values look like, let's see, was this positive or negative? 3, 3, that's a positive 3, 3, 3. So my y values look like they're all positive. They go up to 6. 1, 2, 3, 4, 5, 6, and that's okay. Let's label that so I know what my scale is. And let's just plot our points. 0, 4, 1, 2, 3, 4, right here. We'll label that 4. 12, 0, so 2, 4, 6, 8, 10, 12. Three, 3. So that's 2. 3 is between 2 and 4. 3, and then the scale is 1. 1, 2, 3. -6, 6, -2, -4, -6, 1, 2, 3, 4, 5, 6. And -3, 5. So -2, -3 is right here. Whoops, that shouldn't be a point. And then 5. 1, 2, 3, 4, 5. So notice that I'm labeling each point. It's a good idea to label your points. Actually, if you label the axis, that's probably good enough. If you don't label the axis, then yes, you have to label the points because you have to see what the scale is. And notice that the points that I plotted, except for this one that shouldn't be, let's just put an X there. They all line up in a straight line. Let's see if I have a line tool. No, it doesn't look like it. So let's just see how good I can draw my straight line through those points. So this line represents every solution to this equation. You can use that line to approximate solutions. For example, it looks like there's a point right here at 2, 4, 6, 8, 1. I'm going to put a question mark there. Notice that when I check it, when x is 8 and y is 1, you get 8 plus 3 times 1. 8 plus 3 is 11. Doesn't quite give you 12. So the actual point is up here. It's 9, 1. Should be right here. So it should actually be 9, 1. 9 plus 3 times 1 is 12. So my graph isn't real straight. It gives you an idea of what the relationship between x and y is. It got us in the neighborhood of the relationship. Doesn't always give you the exact numbers. You have to double check by substituting it back in.